Are you excited for today's lesson? This lesson is for grade 11 general mathematics. The topic is inverse functions. Please have your pen and paper for you to write your solutions to the problems later on. This lesson is outlined in this manner. Lesson 1, representing real-life situations using one-to-one functions. Lesson 2, inverse of a one-to-one function. After this lesson, you are expected to represent real-life situations using one-to-one functions. Determine the inverse of a one-to-one functions. We are now in lesson 1, representing real-life situations using one-to-one functions. Have you ever asked yourself how your height and weight predict your BMI or body mass index? How does the power consumption affect the electric bill? How does the number of studying hours affect your grade? This lesson will discuss further how to determine one-to-one functions and its application in real-life situations. What's in? Group the following objects as to their common properties or characteristics. The objects are as follows: triangle, guava, circle, pineapple, crayons, eraser, apple, rectangle, durian, pencil, book, yellow pad, oval, banana, and square. We have 3 columns below. Column 1, write all the shapes. In column 2, write all the fruits. And in column 3, write all the school supplies mentioned above. Are you ready? Please write your answers on your paper. Start now. Remember, you can always pause this video if you want to have more time in answering the activity. Are you done? Let's check your answer. For the shapes, we have triangle, oval, rectangle, circle, and square. For the fruits, we have pineapple, apple, guava, banana, durian. And for the school supplies, we have pencil, crayons, book, eraser, and yellow pad. Now I want you to form some ordered pairs using the format. Let us check your work. For column 1, the ordered pairs are shape, triangle, shape, oval, shape, rectangle, shape, circle, shape, square. For column 2 ordered pairs, we have fruit, pineapple, fruit, apple, fruit, guava, fruit, banana, fruit, durian. And lastly, for column 3, we have these ordered pairs: school supply, pencil, school supply, crayons, school supply, book, school supply, eraser, school supply, yellow pad. How many objects can be found in each column? In each column, there are 5 objects. How did you classify the objects? The objects were classified according to their properties. Based on the coordinates you have formulated, is there a repetition of first coordinates? What about the second coordinates? Yes, there was a repetition of objects in the first coordinates and there was none in the second coordinates. What's new? Representing relations. Given a table, you will be able to learn how to make a set of ordered pairs. In the first column of our table, we have the following foods, or we can represent them as our X values. The second column of our table are the drinks, or we can represent them as our Y values. Let's write down all the set of ordered pairs based on our table. Remember, in forming an ordered pair, the first coordinate is our X coordinate, or abscissa, and the second coordinate is our Y coordinate, or ordinate. The ordered pairs are kamote Q and calamansi juice, banana Q, pineapple juice, hot cake, mango juice, pandesal, apple juice, cheese bread, orange juice. So what elements belong to the first set? The elements belong to the first set are the foods or the X coordinates. How about in the second set? The second set are drinks or our y coordinate. Is there a repetition of the first coordinates? How about the second coordinates? There is no repetition of element in the first coordinates and in the second coordinates. Does the ordered pairs represent a relation? Yes, the ordered pairs represent a relation. How is the relation represented? The relation is presented as one-to-one function. What is it? Now let us represent real-life situations using one-to-one functions. The previous discussion shows that rational function is a function that is a fraction and has the property that both its numerator and denominator are polynomials. In other words, r of x is a rational function if r of x is equal to p of x over q of x, where p of x and q of x are both polynomials and q of x are not equal to 0. Some points to remember. A relation can be presented in many ways: set of ordered pairs, mapping diagram, table of values, graph, or rule of functions. A relation has 4 types: one-to-one, many-to-one, one-to-many, many-to-many. Thus, only one-to-one relation and many-to-one relation represent a function. Let's have the definition. The function f is one-to-one if for any x sub 1 and x sub 2 in the domain of f, then f of x sub 1 is not equal to f of x sub 2. That is the same y value is never paired with 2 different x values. Let's have an example. Number 1 problem. Suppose the Kidzona charge in an hour play is 300 pesos. Your baby brother wants to play in the said amusement. Question number 1. How much will you pay if your baby brother will play 1 hour? 2 hours? 3 hours? How about 5 hours? Solution. If the brother will play 1 hour, the sister will pay 300 pesos. While if he will play 2 hours, his sister will pay 600 pesos. Moreover, if he will play for 3 hours, they will pay 900 pesos. Question number 2. Based on your answer in item 1, write an ordered pair in the form time and amount. Solution. The ordered pairs are 1 and 300, 2 and 600, and the last one 3 and 900. Question number 3. Make a rule or function that represents the given relation. Solution. The rule or function is f of x equals 300 times x. Thus, x represents the time spent in Kidzona, while f of x represents the total charge to be paid. Question number 4. Is the given relation a one-to-one function? Solution. The relation is a one-to-one function since there is exactly one element of f of x in every element of x. Now let's have question number 5. How are time consumed in Kidzona related to the charge to be paid? Solution. The total amount to be paid depends on the time consumed in Kidzona. Now, let's have an example number 2. Suppose you want to call your father by telephone. The charge of a payphone call is 10 pesos for the first 2 minutes and an additional 3 pesos for every additional minute or a half of it. Question number 1. How much will you pay if you call your father for 1 minute, 2 minutes, and how about 4 minutes? Solution. If I will call my father for 1 minute, I will pay 10 pesos. If 2 minutes, 10 pesos. And if 4 minutes, 16 pesos. Question number 2 represents table of values of the given relation based on your answer in item number 1. So to represent this, let's make a table. The first row is the number of minutes of phone call or our X values, while the second row is the total amount or our f of x. The first row, number of minutes of phone call or our X values, we have 1, 2, and 4. Second row, the total amount or the f of x, we have 10 pesos, 10 pesos, and 16 pesos. Now let's proceed to question number 3. Is the relation a one-to-one function? Why or why not? Solution: the relation is not a one-to-one function since there is only one element of f of x in every element of x. Thus, it represents a many-to-one function. Let us proceed now to lesson number 2. Inverse of a one-to-one function. A function and its inverse can be described as the do and the undo functions. A function takes a starting value, performs some operation on this value, and creates an output answer. The inverse function takes the output answer, performs some operation on it, and arrives back at the original function's starting value. Inverting functions. The previous discussion shows that if the x and y values of a one-to-one function are interchanged, the result is a function. But if the x and y values of a function that is not one-to-one are inverted, the result is no longer a function. Let's have the definition. Let f be a one-to-one function with domain A and range B. Then the inverse of f denoted by f raised to negative 1 is a function with domain B and range A defined by the inverse function of y is equal to x. If and only if f of x is equal to y for any y in B. Another definition: a function has an inverse if and only if it is a one-to-one. As shown earlier, inverting the x and y values of a function results in a function if and only if the original function is one-to-one. To find the inverse of a one-to-one function, first, write the function in the form y is equal to f of x. Second, interchange the x and y variables. Third, solve for y in terms of x. This is because we are interchanging the input and output values of a function. For you to understand better, let us try the following examples. Number 1, find the inverse of f of x equals 3x plus 1. For the solution, step 1, write the function in the form y is equal to f of x. So we have y is equal to 3x plus 1. So we change f of x into y. Second, interchange the x and y variables. So we have x is equal to 3y plus 1. Third, solve for y in terms of x. X equals 3y plus 1. So we are going to subtract 1 to both sides of our equation. We have x minus 1 equals 3y. To get the value of y, we have to divide both sides of our equation with positive 3. So we get y is equal to x minus 1 all over 3. Therefore, the inverse of f of x is equal to 3x plus 1 is x minus 1 all over 3. We have these questions. Number 1, what is the inverse of the inverse? Let us use the solution from example number 1. which is the f inverse of x is equal to x minus 1 all over 3. Now, what is the inverse of the inverse? To solve for the inverse of f inverse of x is equal to x minus 1 all over 3, we have to inverse the inverse of f of x. Solution. First, write the function in the form y is equal to f of x. So we have y is equal to x minus 1 all over 3. Second, interchange the x and y variables. So we have x is equal to y minus 1 all over 3. And then, we have to multiply both sides by positive 3. So we have 3x is equal to y minus 1. To get the value of y, we have to add positive 1 to both sides of the equation. Then we get y is equal to 3x plus 1. Therefore, the inverse of the f inverse of x is equal to x minus 1 all over 3 is f inverse of x is equal to fx, and that is equal to 3x plus 1. As you noticed, our original function is y is equal to 3x plus 1, and the inverse of it is f inverse of x is equal to x minus 1 all over 3. Now, if we are going to inverse the inverse of our original function, we will go back to the original equation. Now, let's have the question number 2. What is the f of f inverse of x? And how about the f inverse of f of x? For the solution, solving for the f of f inverse of x and f inverse of f of x, given the function f of x is equal to 3x plus 1 and the f inverse of x is equal to x minus 1 all over 3. Solutions. F of inverse of x is equal to 3 times x minus 1 all over 3 plus 1. So that is equal to x minus 1 plus 1. So the f of f inverse of x is equal to x. Another one, f inverse of f of x is equal to quantity 3x plus 1 minus 1 all over 3. That is equal to 3x all over 3. Now the f inverse of f of x is equal to x. From our solutions, we can summarize the properties of an inverse of a one-to-one function. Now let's have here the properties of an inverse of a one-to-one function. Given a one-to-one function, f of x and its inverse, f inverse of x, then the following are true. First, the inverse of f inverse of x is f of x. Second, f of f inverse of x is equal to x for all x in the domain of f inverse. Third, f inverse of f of x is equal to x for all x in the domain of f. Let's have another example. Find the inverse of g of x is equal to x cubed minus 2. For the solution, first step, write the function in the form y is equal to f of x. So we have y is equal to x cubed minus 2. Next step, interchange the x and y variables. So you have x is equal to y cubed minus 2. And third, solve for y in terms of x. So we have x plus 2 is equal to y cubed. Now since y is raised to positive 3, we are going to cube both sides of the equation to eradicate the square root sign. So we have y is equal to cube root of x plus 2. Therefore, the inverse of g of x is equal to x cubed minus 2 as g inverse of x is equal to cube root of x plus 2. And that ends our lesson for today.